Hey everybody, welcome to another session in this math class. Today we are going to discuss a very interesting and important topic in discrete mathematics called permutations and combinations, right? So as you see on the screen, we have two fundamental questions that bog up when we talk about permutations and combinations, and then we are going to take up a simple example that basically helps us solve these two questions, right? So let's see what are these two questions that permutations and combinations is trying to address. Let's take a whiteboard. Let's say you have 5 chairs, right? Like this. Yeah, let's assume this is a chair, okay? And then there are 3 people, right? A, B, and C. Okay, so 3 people. You want to place these 3 people among these 5 chairs. So in how many possible ways can you place these 3 people on these 5 chairs? So let's say the person A can occupy any of these 5 chairs, right? So basically A has 5 choices, all right? Any of these 5 chairs. Suppose say A occupies the second chair. So how many chairs remain for B to occupy? Just these 4 chairs, right? 1, 2, 3, and 4. So after A has occupied his chair, B has only 4 choices, right? And then after B, let's say B occupies this chair, right? So how many choices has C been left with now? Just 3 choices, 1, 2, and 3. So after both A and B occupy their chairs, C has only 3 choices left, right? So the total number of ways in which they can occupy these chairs is basically 5 multiplied by 4 multiplied by 3. As simple as that, right? It's just 5 multiplied by 4 multiplied by 3, right? So suppose you had, say, not just 5 chairs, but let's say you had, say, n chairs, right? So let's come to this n later. So like, if you want to write this 5 multiplied by 4 multiplied by 3, another way of writing that is that say 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 divided by 2 multiplied by 1, right? So just because that this 2 and this 2 into 1 gets cancelled, all remains is 5 into 4 into 3. But then if we come back to the numerator and the denominator, the numerator is basically nothing else but 5 factorial, right? 5 factorial is 5 into 4 into 3 into 2 into 1. And the denominator is nothing else but it's 2 factorial. Okay? Now this 2 factorial is nothing else but it's basically 5 minus 3 factorial. So we are just rewriting the denominator in terms of 5 minus 3 is 2, right? So 5 minus 3 factorial is 2 factorial. So the expression can be rewritten as 5 factorial divided by 5 minus 3 factorial. This 5 is nothing else but is the number of people. Let's say it's n, the number of people, the number of chairs. Let's say it's n. And this 3 is nothing else but the number of people, right? Let's say it's r. So in general, for permutation of n and r, you write this as n factorial divided by n minus r factorial. So that's your expression for permutation. So you write it as n p r, or maybe like say p n r equals n factorial divided by n minus r factorial, right? So this is your permutation, right? Now, when you talk about combinations, right, what are we trying to basically address? Let's take the same problem. Let's say we have these 5 chairs, right? And then we have these 3 people, A, B, and C. Now we just saw on the top that the number of permutations, the number of ways of arranging these 3 people among these 5 chairs is basically 5 factorial divided by 5 minus 3 factorial. So this comes out to be how much? Basically, it's like 5 into 4 into 3, right? So it's 60, basically, right? 60. So there are 60 different ways in which we can arrange these three people among these five chairs. But now, if I want to ask myself a question, is that let's say A sits over here and then B sits over here and then C sits over here, right? So let's say we have this arrangement. Now suppose I want to regard, like say an alternative arrangement, like say, let's say for example, A sits here and then let's erase this file. Let's say A sits here. Now we are talking only of these three chairs, this chair, this chair, and this chair. And now let's say the order in which they sit is not important. Let's say A sits here and then C sits here and B sits here, okay? Or maybe C sits here, B continues to sit here and A sits here. I mean, that's the same thing, I'm sorry. Uh, let's say C sits here, A sits here, and B sits here, or maybe B, C, and A, so on and so forth, right? So like, if we consider, okay, now all these different arrangements, right, among A, B, and C, restricted to these three chairs, right? So as long as A, B, and C are sitting anywhere on these three chairs, doesn't matter where C is sitting, where B is sitting, where A is sitting, I'm considering all of them to be the same. So here, the order in which they sit is not important, all right? So how many such arrangements between A, B, and C can we have in these within these three chairs? It's going to be basically 3 by 2 multiplied by 1, right? Because C can occupy, say, any of these three chairs. After C occupies this chair, B can occupy only two chairs, and then A can occupy just one chair, right? So it's basically 3 factorial, right? And in case of this expression, right, we'll come back to that later, it's basically 3 factorial, right? So in 3 factorial ways, A, B, and C can arrange themselves within these three chairs only, these three chairs, 1, 2, and 3, right? So if we consider, okay, all of these are the same and order is not important, then, so now considering the fact that the order is not important, in how many ways can I choose A, B, and C, these three people to sit among these five chairs? The answer is going to be like the number of permutations, which is 60 divided by this number, right? 3 factorial, correct? Because I want to divide by all these occurrences. I want to consider them the same. So I have to divide them by these occurrences, right? So it's 60 divided by 3 factorial. Okay, so what is this 60? It's basically nothing else but this NPR. So in general, so this 3 factorial is nothing else but this 3 is basically R, right? The number of people. So in general, a combination CNR or basically NCR is nothing else but it's N factorial divided by N minus R factorial. So this is the permutation divided by R factorial, right? The permutation divided by the factorial of the number of entities amongst themselves. So in general, the formula for combination becomes NCR equals CNR equals N factorial divided by N minus R factorial into R factorial, right? So in this way, we have derived, we have understood what are permutations, we have understood what are combinations, and then in this way, we have derived both these expressions for permutations and combinations, right? So this is your permutation and this is your combination. So I hope this was useful. I hope now it's clear what are permutations and what are combinations and why we have the expressions, these expressions the way they are, right? So until then, I would now allow you to contemplate on this. If you have any questions, please feel free to message and comment in the box at the bottom of the video. Until then, continue with your studies, enjoy your mathematics, and then see you in another video in some other session, right? So until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another